In this video, we're going to solve compound inequalities that are linked together by the term and. The most difficult thing regarding these inequalities is that graphing the solution really tends to confuse some of our students. What's important for you to remember is that the values of x that solve the inequality are the values that are greater than 3 and at the same time greater than -4. So let's take some time and let's go ahead and graph a solution to one of these inequalities. So what I'm going to do is I'm going to graph x is greater than 3. Well, x is greater than 3 would be going over to 3, open circle at 3, and shading over to the right. Now you'll notice what I did is I didn't shade my solution directly on the number line. I shaded it just above so that later on I can shade my exact solution on the number line. Now I'm going to graph x is greater than -4. Again, an open circle at -4, and I'm shading to the right. Well, if we look very carefully, where's the area where both inequalities are true? Because that's the area of my solutions. Numbers like 4 and 5 and 6 and 4.5. Numbers that start at 3, not including 3, because 3 is not shaded with the blue line, and go over to the right. So the solution that x is greater than 3 and x is greater than -4 is actually just all of the values greater than 3. So I can simplify this expression just by writing x is greater than 3. So let's try another of these compound inequalities, but this time we're going to have to solve them first. Well, solving them is really the easy part. I'm going to subtract 6, so I get 2x is greater than -10, divide by 2, x is greater than -5. On the right hand side, I'm going to subtract 1, so -3x is greater than or equal to -3, divide by -3, remember to flip my inequality sign, so x is less than or equal to 1. And I need to remember that these two inequalities are linked with the term and. Now on the number line, I'm going to shade them very carefully. I'm going to start with the x is greater than -5. So -5, open circle, greater than means I'm shading over to the right. X is less than or equal to +1, 1, close circle, +1, shading over to the left. Now looking very, very, very carefully at that set of solution. Where are the numbers that fit both? Where are the numbers that are greater than -5 and at the same time less than 1? All of the numbers in between. The numbers like -4, 0, -1, -1.5. The numbers from -5 to 1. Not including -5, but including the +1. You'll actually see this solution sometimes written as -5 is less than x, which at the same time is also less than or equal to +1. That actually might be a much simpler way to write this solution, and it actually becomes a very easy way to create a graph. That being said, let's look at an inequality that's already set up as a single inequality with two inequality signs inside of it. This just means that this is an and problem, and it actually may be easier for you to solve if you just remember that we're isolating the x in the center, and whatever we do to the center of the inequality we have to at the same time do to both sides. So if I subtract 4 from the center to get the x by itself, I have to subtract it from the left as well as from the right. So now I'll get -8 is less than or equal to 2x, which is less than +6. I'll divide by 2, divide by 2, divide by 2. -4 is less than or equal to x, which is less than 3. Again, -4 is less than or equal to x, and at the same time, x must be less than 3. So in graphing this inequality, I'm going to put my line at -4 and my line at 3, and I'm actually going to cheat a little bit. I'm not going to use my graphing method that I was using in the last problem, because I know that x is all of the values in between -4 and +3, and that's what makes this style of a compound inequality easier to follow, so that it's much easier to graph. It looks that x is in between those two numbers, and in fact, in my graph, x is in between those two numbers. So that's my solution, and there's my graph.